Hello, my name is Christopher DeLay. So the reason I'm talking to you today is just going to be hopefully the first in a several part series on kind of just fundamental PKI training. I was kind of going through Reddit today and I was looking, there were some comments on some individuals that were looking to get, some sort of training on some sort of PKI basics. So I thought it'd be interesting since I have like 10 years plus experience with PKI to go ahead and kind of give some, kind of fundamental training for those that are interested in. So a little bit about these series. I don't really have a lot of free time to do these, but I definitely am interested in helping out the community. So there's not going to be any elaborate graphics or anything like that. It's going to be mostly me talking, so hopefully you all can deal with that. And then depending on the feedback I get, then maybe I'll make things a little bit more polished and a little bit more intricate if there is lots of interest. So if this video does work out for you, definitely just go ahead and recommend that to other folks. And also, if you want to contact me, you can reach out to me. I have a contact page on my blog that's listed on the screen right now, and you can go to there and send me comments. If you really thought this training was helpful, let me know. If there's some particular area you would like me to go into, let me know. If this training was awful, let me know that as well. So yeah, so based on the feedback and how many views I get and things like that, I'm going to continue and put more time into this. So again, my name is Christopher DeLay. My current blog is listed there. I used to previously post on TechNet blogs, originally on the Ask DS for that directory services team, and then later on my own TechNet blog. They've kind of closed down those TechNet blogs, so I'm just kind of started a blog under my own blog, and hopefully if you go there, you'll find some useful information. So today, I'm really just going to talk about certification authorities and kind of from a point of view of somebody who's new to PKI, sort of kind of describe them. And if you got, like it said, if you have any questions, you can follow up. I'll leave comments on this video. And so you can send them there, or you can go to my blog and post questions there. Granted, I am doing this kind of on the side, so I don't have unlimited time to spend on this or answering questions, but I'll do the best that I can. So when you're new to PKI, one of the things you may be, you heard about these certification authorities because they're so central to PKI and certificates. And so it's kind of like, what do these certification authorities do? What are they? That sort of thing. So first, from a standpoint of a certificate, right? A certificate is a digital document that binds like a public key to an identity. So the key things in a certificate obviously are the key pairs and the identity. And so PKI is considered all the things around managing those certificates, issuing them, revoking them, validating them. So all that's part of the PKI. Certification authorities are just one component of the PKI. So the primary functions are the top three here that are, at least I'm most familiar with the certification authorities in Microsoft's Active Directory Certificate Services. So the main functions that the CAs do from that standpoint are issue and manage certificates. So that's who issues That's who issues you your certificate. And there's some management that can be done in the CA. So what does that mean? So when you go to request a certificate, you generally submit that request to the CA. There are some, we're not going to get too technical here because I'm trying to keep this kind of like an overview type thing, high level view, but there are other ways to enroll that involve different servers like Cisco SEP protocol and other methods like that. But if you're using a CA in a Microsoft environment, most of the requesting and issuing of certificates is done directly over to the CA. So you send a request to the CA and the CA issues a certificate. As we have time to maybe go in future videos in more technical detail, we'll talk about how all that happens. But you request a certificate, you get issued to the certificate by the CA. As far as managing certificates, so how does the CA manage certificates? So the one way that it manages certificates is so like when our CA issues, or when a CA on a Microsoft CA issues you certificates, it stores a copy of that certificate in the database, and then so whoever's administering that CA, they can go through the database and look at your certificate. They can revoke your certificate. The other thing is there's different ways the certificate can be issued. So if you're using like auto enrollment, you'll do a request for a certificate and it'll get issued right away because the CA basically validates your identity through like Kerberos authentication. But there are some types of certificates that may not get issued right away. So if an organization is following best practices, if you submit like a manual request for like a web server certificate, then best practice is that the certificate manager reviews that request and makes sure that it's appropriate before they issue that certificate. So that's some of the management functionality. And so in that particular instance, it's just making sure you're requesting domain names that actually exist in your environment, that sort of thing. That's what they're sort of going through and validating. So the management is not just being able to revoke the certificates, but it's looking at incoming requests and see whether they should be approved. And then also determining what type of certificates are available and what types of certificates can be issued. In the Microsoft CA product, it's basically we use something called certificate templates to determine what sort of certificates are issued. So again, the first role is basically to issue and manage certificates. And then how those are validated, we're going to talk about that in a little bit because I'm not talking about the whole chain right now, just specifically what the CA does. And so the CA is also responsible for revoking certificates. So once the certificate manager or the CA manager decides the certificate has been revoked, so for example, a machine has been compromised or whatever the case may be, they go in on the CA and revoke that certificate. When they revoke that certificate, it publishes, eventually it gets published to a CRL, so the serial number and the date of revocation, and usually the reason for that revocation are stamped in a CRL at some point, and that CA publishes that CRL. And that CRL is published to what's called a CRL distribution point. And so when someone wants to determine whether that certificate has been revoked, they go to that CRL distribution point and download the CRL and see if the serial number of the certificate they're checking is in the CRL. If it is in the CRL, then it's been revoked. If not, then it hasn't. There's a little bit more complexity to revocation, but that's kind of like how it works from a kind of overview standpoint. There's other ways to do revocation. There's all sorts of other things that maybe we'll talk about in future videos, but the gist of it is once your certificate is not considered trusted, it can be revoked, and then it can the CRL will be published and clients will check the CRL to see whether things are revoked. So that's the other thing that's handled. So far we have issue and manage certificates and revoke certificates. And then the third thing is a registration authority. So basically a registration authority is a person or a service or a computer that goes through and reviews certificate requests and determines whether they should be issued. So if you were to go to like VeriSign or Thought or whatever the case may be to get a certificate for your domain name, you definitely have to show them that you have ownership of that domain and that that domain is your company. So you're going to have to provide them some documentation typically before they're going to issue a certificate. So that's pretty much the registration authority, is that person or service that sort of verifies that. Now, so if you use the CA that's in Windows, typically the way that we validate the identity is through Kerberos authentication. So you basically use Kerberos to authenticate to the CA, and that's how it validates your identity. Based on your identity, you'll have the ability to request certain certificates from the CA. And depending on the certificate, sometimes certificates pull attributes from Active Directory and populate that in the certificate. So for example, if you were enrolling for a user certificate, it may pull your user principal name from the Active Directory attribute and fill that out as the subject or subject alternative name. For a computer, it might pull like the service principal names or the DNS name or something like that. So it might pull the DNS name from the DNS hostname attribute and then populate that in as identity information in terms of the subject and the subject alternative name. And then, so those are the key things that the CA does. It issues and manages certificates, and it revokes certificates, and it acts as a registration authority. We'll talk in a later video about certificates. I was debating whether to do certificates or CAs first, so just start off with CA. So we'll get to certificates next session. But as far as Microsoft product is concerned, there's really two types of CAs. There's a standalone CA and the enterprise CA. So the main difference, I mean, this isn't really industry sort of naming. This is just kind of like within Microsoft technology. So if you asked some other company that has a PKI product and you ask them what a standalone CA or enterprise CA is, they may not necessarily know because it's specific to like a Microsoft product. But the standalone, basically the main difference here is the standalone CA does not use certificate templates, and the enterprise CA does use certificate templates. Again, we'll go into more detail on this in a future video, but basically certificate templates are exactly what they sound like. They're a template for requesting a certificate. And when you use them, it requires Active Directory integration because that allows us to automate certificate issuance and do a number of other things. And we'll talk about, in a second, we'll talk about the hierarchy, and we'll kind of talk about how they relate to the hierarchy. So here's two types of hierarchies. The one on the left is a 3-tier hierarchy because it's 3 tiers, obviously. And then the second one on the right here is a 2-tier hierarchy. Most PKIs that you see in corporate environments are the one on the right, where you have basically 2 tiers. So first we'll talk briefly about the one on the left, the 3-tier hierarchy. So in this example, you have a root CA. So the root CA's main thing is to be the trust anchor for the PKI. So if your machine trusts the root CA, then you'll trust the policy CA underneath it, and you'll trust the issuing CA underneath it, and you'll trust certificates that are issued by the issuing CA. So that's how that trust is formed to a PKI. As you're probably aware, there are a number of certificates that are distributed with Windows, so there are some PKIs that you already trust. And of course, a system administrator in your environment can choose to add other CAs that are trusted. And usually if you have an internal corporate root, that will be trusted and put into the trusted root store. So any device that wants to use the PKI essentially has to have that root CA at the very least. So whether that be a Windows computer, a Linux computer, Apple iPhone, Cisco router, switch, anything that wants to trust that, any sort of appliance you have really has to have that root CA in place. And so again, the root CA's main responsibility is as a trust anchor. In this example on the left, the root CA will also issue a certificate to the policy CA. And it will also issue a certificate revocation list. And so the root CA can revoke the policy CA in effect. And so basically that root CA will be copied off to the CRL distribution point because the root CA is really supposed to be kept offline. And so offline, that means not connected to the network. And that just protects it from any kind of security kind of attack since it's not on the network. And it's sort of counterintuitive that you have a computer and it's not on the network, but that's really just there for the security of the root CA, because the idea is you can have, you can of course have multiple CAs underneath the root CA. So I mean, the main thing is the root CA is trusted in your environment. So if somebody were able to compromise the root CA, they can issue CAs that are trusted. They can issue certificates that are trusted in your environment. So that's really why it's meant to be offline. And you might say, well, how about some of these other CAs? Like, is the issuing CA offline? Well, so when you get into that argument, the main idea is that the root CA is offline, not only because the security implications, but because it does not have to be online all the time to do its function, right? This root CA is going to, in the left-hand example, the root CA is going to issue a policy CA certificate, maybe like once every 5-10 years, something like that. And it's going to issue maybe a CRL maybe once a year. So there's no reason to keep that root CA in a position where it can be compromised just to issue these files, at most once a year. In the example on the left, we have a policy CA. So it's just called a policy CA because sometimes there's policies that are set at that level, like name constraints and things like that could potentially be set at this level. So it's just again, the policy CA, much like the root, is offline because it's only going to periodically, maybe like once a year, publish a CRL and periodically publish like an issuing CA certificate because it signs issuing CA. And so you're probably thinking, well, this policy CA doesn't seem like it really does that much. It doesn't really seem that helpful. And that's pretty much true. And that's why we don't really advocate for 3-tier PKIs anymore, or at least I don't. So what's an example where this 3-tier PKI would be used? So one example is if you had a large multinational conglomerate, right? And a conglomerate corporation is going to have a bunch of different companies underneath the main company, holding company, or whatever the case may be. And so in that situation, if you wanted to give like each company give it some autonomy but still have it trust the same root, then you could have like whatever is the shared IT for the conglomerate basically run the root CA, and then you could have like each company have their own policy CA. And what that would allow is for each company to create their own issuing CA. So like the company would need to go to the shared services initially to get their policy CA signed, but once they did that, they could add or remove issuing CAs at will, and they'll be trusted in their environment. So that provides them the same sort of trust infrastructure, if you will, but still allow them some autonomy in terms of adding or removing their issuing CA certificates. And so, like I said, policy CA is much like the root CA is kept offline. It signs the issuing CA certificate and publishes the CRL, so the policy CA can revoke the issuing CA. The example on the right is what we commonly see, and what I recommend is it's called a 2-tier PKI hierarchy. So basically you have a root CA. Its job is pretty much the same as in the other example. So its main responsibility is to be like the trust anchor. The root CA, of course, is a self-signed certificate, so the root CA signs its own certificate, and that's the certificate we either choose to trust or to not trust. So like, for example, in Windows, not only can you put certificates in the trusted root certification authority store to trust basically the PKI, you can also add, there's also an untrusted certificate store where you could add root CAs as well if you specifically did not want to trust them. I guess distrust them, I guess might be the word there. So that is the trust anchor, and then in this example you have the issuing CA. So the issuing CA is responsible for issuing certificates to clients. Again, for if you're using the Microsoft product, there'll be most of it's going to be like direct enrollment to the CA. So we happen to use RPC for direct enrollment to the CA. So most of your internal clients or even servers are going to get certificates by talking directly to the CA. There are some other services that can kind of also request certificates. So like there's our network device enrollment server, which supports Cisco's simple certificate enrollment protocol, which was originally created to allow like network devices like routers and switches to request certificates, but it's used by like a lot of MDM, mobile device management software today. There's also there's a web enrollment website that you can set up. So like if somebody creates like a certificate request in OpenSSL, they could submit their request through this website and get a certificate back. That certificate enrollment web services website hasn't been updated in a long time, but it may possibly provide some functionality in your environment, although you can do a lot of those things with the certificates MMC. And then there's certificate enrollment web services. So this is another way, and not a commonly deployed way, to request certificates, and it allows you to use other types of authentication other than Kerberos. So it allows you to use username and password and certificate authentication. So it opens up some different scenarios there. But this is basically the hierarchy. So these are the CAs. You're going to have to trust the root to trust everything underneath it. So the root CA you'll see show up in your trusted root certification authority store on Windows. And so how that gets there is some ship with Windows. Your company can deploy those to your machines either by publishing them in the right spots in Active Directory or through group policy. And as far as Windows is concerned, like all these CAs will get published to Active Directory. So you'll see like the policy CA and issuing CA show up in the intermediate certification authority store as well. So all these certificates stored to Active Directory, and for Windows clients, they all get kind of pushed down. If you're in your corporate domain, they all get pushed down to the client. Yeah, obviously, if you are a non-Windows client, you need to find a way to do that, to kind of publish those. only other thing I can think about in the chain is so like we talked about how devices would need to have like the root certificate installed to trust the PKI. So what about the issuing CA? Well, like I said, Windows clients with the issuing CA published to them through Active Directory mechanisms. But there's also, if you look in a certificate, there'll be a field called Authority Information Access. And that basically provides like a URL. It can be either HTTP or LDAP, where basically the CA that issued that certificate can be retrieved. So for example, see if I can pull up my little laser pointer thingy. Okay, so for example, if this issuing CA issued a certificate, so we have this pretend invisible certificate here. So for you to trust that certificate, you would have to trust the root. And so let's say you have the root and then you have this invisible certificate down here. There's no way for you to know whether that certificate changed to the root unless you have this intermediate CA certificate. It's just impossible. There's no way to figure that out. So you need to have possession of this issuing CA certificate as well. So on some devices, you may just have to input the root and you may be like mystified, like, okay, well, how does it get this subordinate CA certificate? Well, in our invisible certificate here, basically there'll be, I really don't like the idea of using an invisible certificate here. So let's see if we can insert something. Okay, here's our certificate. So this green box is our issued certificate. So again, if in order to trust this certificate, you would need to basically get my laser pointer back up. So basically to trust this issued certificate, you would need to have possession of the root CA certificate and it need to be in your trusted root store. And some other OSs and devices are going to have something equivalent to the Trusted Root Certification Authority store. Now Windows, like I said, kind of repeating myself, but Windows boxes that are domain joined will get this issuing CA, excuse me, pushed down to them. But there may be some appliances where you just install the root and you don't necessarily install the issuing. There may be something like that. So in those scenarios, what happens is there's what's called an AIA extension, Authority Information Access extension, in this certificate. And it basically has either, well, it can have an HTTP and or LDAP URL where it can retrieve this issuing CA certificate. And so basically if it has the root, well, basically what it'll do is it'll say, oh, I don't have the next cert in the chain. I checked all my stores, it's not there. So it'll go to the AIA and download that cert. Once it has that cert, it'll be able to figure out that this cert changed to this cert, that changed to this cert, and so it can see it terminates in a trusted root. I'm not going to get into revocation too much, just want to talk about it from a basic point of view here. But so as far as certificate validation, that's one of the things that needs to be completed, right? We need to build that certificate to a trusted root. And so the other things is all these certificates in here need to be time valid, right? They can't be, if their expiration date was yesterday, then they're not time valid today, as an example. Or if their begin date is tomorrow, they haven't really started yet, so they're not time valid either. So they need to be time valid. And again, we'll cover this in more detail when we get to the certificates and revocation and stuff like that. But these all need to be time valid, and also we need to check revocation. So for in Windows, we don't check revocation for the root CA. And you might say, well, why is that? It seems kind of weird. Well, the thing is, you either trust the root CA or you don't. I mean, if you think about it, if the root CA was publishing a CRL for itself, then it would be kind of a weird scenario where you're not really sure whether you should trust this thing, but you're trusting it to revoke itself. So basically, it doesn't really make a whole lot of sense. So either you trust the root CA or you do not. So it's a pretty simple binary decision there. So based on that. Based on this, we just check revocation for the entity certificate. So we check to see whether that's revoked, and then we check to see whether this certificate is revoked. So basically, without going too much in revocation, this root CA publishes a CRL that can revoke this issuing CA certificate, and this issuing CA publishes a CRL that can revoke this certificate. So when you're validating this certificate, you look for the CRL that this CA published, you find it from the CRL distribution point and check whether the serial number of this cert is in that CRL. And then same deal for this. You're going to have to locate through the CDP location in this certificate where the CRL that's published by the root CA exists. Go there and check and see if the serial number for this CA exists in there. And that's basically the whole process. So that's the whole process as far as chaining everything, as far as certification authorities, anything else I can think of. If you guys really like this video, then maybe I'll come back and go in more detail, bring up like a CA that's in a virtual machine and kind of maybe go through some of the management and stuff like that. But hopefully this was helpful. If it was not helpful, again, the target audience for this is really just people that are really new to PKI. So we're going to start at a real basic level. So if this video is helpful, let me know. You can contact me through my blog. You can leave messages underneath the YouTube video, whatever works for you. And when I get time, I can't promise it'll be within a day of you posting your question or whatever. I'm going to try my best to get back to you. So basically, let me know whether this video is helpful, not helpful, if there were things that you thought should be in this video that weren't, anything like that. So I appreciate you all for viewing this video, and again, I hope it was helpful for you. Anyways, see you next time.